Getting started on that new set of notes from the red folder. I'm going to take attendance, and while I'm doing that, I'm going to pass around my inbox. If you have your problem set ready to go, you can turn it in. If not, that's good. You got till the end of the day to have it in my box. Okay, Angelica. Dennis. Nelson. Gladys. Cecilia. Eileen. Edo. Tanya. Andres. Jacqueline. Alba. And Jordan. So seeing if you can graph this function and then find where it's increasing, decreasing. Oh, it should be floating. It exploded. Yeah. But do you think so? That's the old one? Yeah. Or the new ones? Sometimes check still works.
Yeah, they still work.
Graph it, see if you can find where it's increasing, find where it's decreasing, and then the third one is going to be kind of new, calculating the slope. That's what we're going to talk about today. Let's see what you can come up with.
This is what is
That's what was in your. But all these are on the right page, right? Okay. Let me just keep this one. It'll be an extra copy. It's just, it looks like it's just stapled. Y'all good? Cool. Anyone else here? You don't read them? Where is it increasing? Where is it decreasing? Would you put minimum or maximum? So we're looking at this graph, is it a minimum or maximum? Yeah, it's like a low point. So like if you put max, all it's finding is like the biggest point, you want the smallest, so use min. This is just and try it again. Good. Very nice, very nice. Give you about 30 more seconds, see what you can come up with. All right. Happy Monday. How y'all doing? And anything fun this weekend? Anyone work? Work? All the things? Nothing to share? What did I do this weekend? I watched a lot of football. UT had a game and we won. Very exciting. Then yesterday I watched some NFL football. Texans did not win. Didn't do so well. Mm-hmm. Yeah. Do I bet? Nah. No betting on the games, just watching. I watch definitely don't really miss usually UT football games. And then I watch some NFL. Last week we lost, and we shouldn't have. So that was kind of like bad game. And then this week we won, but I wouldn't say we looked like wonderful because we again were playing a team that we kind of should have won. But we'll see next week. Next week we play USC, and it should be really difficult. But anyways, okay. Well then, I guess we'll get started if we got nothing else to share. So taking a look at this quadratic, I saw a lot of people love it that like Friday went ahead and just graphed it like we did on Friday and used their tool to find the min or the max and use that to find increasing or decreasing. Fun fact though, I think Andres and maybe a few other people that also realized technically with this, since it's a quadratic, we actually have all the skills that you could have used to do this by hand. Like for the vertex, for a participation point, anyone remember, one more time, you don't have to like solve for it, but anyone remember how I can find this x coordinate of my vertex if I have ax squared plus bx plus c, Dennis? Good, so I saw Dennis did this and he got like -3/10, which is like -0.3. And then you could take that and you could plug it in and you'd get -2 point, what did y'all get when you did it on your calculator? -2 point and something, 4. I saw a bunch of people that had it. Did y'all have it right there? -2 point, what was it? No, didn't get there? You got it right now? 4.5. I couldn't remember if it was like 4.5 or 4.7 from this morning. Okay, so when you plug it in, you could have gotten that by hand, or I saw a lot of people that just went ahead and graphed it on their calculator. If you were on a calculator section, that would be completely valid, and I didn't really clarify here. And they went and they found this minimum value, which is your vertex, and when they used the minimum tool, this is what you should have gotten there as well. Okay? And if not, I can help you out with like zooming and stuff, but we can take a look. Cool? So that's what we have for our vertex. Therefore, out in the crowd, I'll give you a stamp for earlier. Where is our function first increasing? Based off of what we talked about Friday, where is our function increasing? Tanya, go for it. Where it goes like this, she says, which is correct. So from the vertex, is it like the left side or the right side?
The right side.
This right side right here. Okay, perfect. So she described it. It's the right side. So it says express your answer using interval notation. Who thinks they can tell me that part of our graph, the x values, in interval notation? I saw some people that have it, so be brave. In interval notation. Yes, Eileen. Perfect. We start at x is -0.3, and for any x values all the way to infinity, it's going to be increasing. And I used parentheses because I can't really say that at -0.3 it's increasing yet, because it's right there at the bottom. Okay? Cool. Decreasing then is going to be this other side. Alba, you think you got that one? Where would it be decreasing? Yeah, the interval notation. The opposite, this side right here. How do we describe that side?
It would be negative infinity, I believe.
Perfect.
And
All the way to, where do we stop?
-3.
Woohoo! Cool. Parentheses again, because I also can't say it's really decreasing. Did you? Right there either. Okay, so that's kind of like a quick recap of a little bit increasing and decreasing, but with a quadratic. Again, a quick reminder, if you did not already turn in your problem set, that was the last thing you had to do on problem set, was that section on extrema, and then you could stop at average rate change. So I need that by the end of the day. Cool, if I didn't already get it. All right, so today, what we're going to talk about is kind of this third one, which you might have gotten started on, but you might have not been sure what I meant for you to do here. It says, using skills obtained in Algebra 2, calculate the slope of the line that contains the point -2, 12, so like somewhere like that, and then 352. Technically, we refer to this as a secant line because it passes through 2 points on the graph. Raise your hand if you've ever heard this word slope before. You might not even remember what it is, but you've heard the word slope. Should have about like every hand in here. We've probably heard the word slope. Anyone remember anything they have to share firsthand? Anything and everything you remember about slope, or what does it sound like? What is the slope? Yep, Angelica? Yeah, she's like, it's like this, right? It has something to do with like, this is the slope, okay? Other thoughts? Yep. Cool, can you say that just a little bit louder so I can make sure everyone heard you?
In a linear type of graph, you have to find the rise over 1 in order to get your slope.
Okay, so just like Angelica said, right, it's something like this. It's describing something about like this. The slope of like, if you are skiing or doing whatever, it's like the slope of the mountain. Maybe you think of as with a line, a linear function. She says it's like your rise over your run. Like you might say you go over and up a certain amount and it stays constant. Okay, you might have seen this before. So rise over run, you might have also heard it as like change in y over change in x. Anyone, is that something familiar? Because it's like the difference in how your y's are changing over your x values. Okay, so what we're gonna find is actually the slope of, because it's a line, not the curve right here, but if I were to pick 2 points on my curve, where did it go? If I were to pick like 2 random points on my curve, I want to find the slope of that line because it still kind of tells me, not about the entire function, but it still tells me in general a few things about the function that we're going to talk about today that are important, okay? So we want to find the slope when these are 2 points. So I'm going to come up here where I kind of have some more space, but we're on this last third one down here. If I want to find change in y over change in x, and these are my points, let's find our y values. There they are. So what can I do for my change in y? Yeah, Tanya, a little louder. Subtract. So I can do like 52 minus 12 over, and then my change in x then would be, writing this down for the third one if you haven't already, 3 minus -2. And it actually does not matter which one I started with, 52 or 12, as long as I'm matched up, like this is the y coordinate that goes with this x value. If I would have started with 12, then I would have needed to start with -2 on the bottom. Okay? Go ahead and really quick calculate that for me, see what you get as your slope of the secant line. Calculate that for me, see what you get for the slope of your secant line. And then I'll pick someone from the sticks, so everyone should be ready. Cecilia, what'd you get?
Is it 40?
Not quite, not quite. 52 minus 12, I believe you get 40 on the top, right?
Yeah.
Divided by 5 on the bottom, what do you get? 8, perfect. So our slope of the line, clearly this is not our line because this has a negative slope. The slope of the line connecting those 2 points is a +8, which is going to tell us some things about the behavior of that function. Even though it's not the perfect like slope of the entire line, it's just like a piece of our graph. Okay? Cool. So let's talk about the slope of lines today by discussing something we call the average rate of change. The slope is like a rate, and we're going to be talking about the average rate of change as we go through our function. All right, here we go. just so that I am not talking the entire time, I just want to read up here where it says in algebra you learn. Tanya, go for it, nice and loud.
In algebra, you learned that the slope between any 2 points on the graph of a linear function represents a constant rate of change. For a non-linear function, the slope changes between different pairs of points, so we can only talk about the average rate of change between any 2 points.
Okay, so this is what I kind of talked about before. Rise up here. If this is a line, it has a constant rate of change. It's like steps. I go over and up the same amount. If I have a curve, I go over and up a certain amount, but then I go over and I go up further. I don't go up the same amount necessarily, right? So my slope is changing. So the only thing I can talk about is on average. I can find like an average of this and find on average what's happening with my rate of change, okay? So we're gonna be finding like average slopes today by using a secant line. But the cool thing is that we're still gonna be doing change in y, or I'm gonna refer to it as like change in our f of x, because we're gonna be talking about functions, but that's change in y over our change in x. So if you wanna write right here, like add on to your notes, because maybe you're like, I don't really know what that means. We're just still talking about the rise over the run, or the change in y over the change in x of our function. All right, flip to the next page. Let's take a look at some of these examples. I'm going to come back to that box that says say it, and we'll talk about that once we have our answer. How do we like say our answer? Well, let's jump right here. Oh, sorry, right here. Boop, into the middle of the page where it says example 1. It says find the AROC. That just stands for average rate of change, but so that I don't have to type the whole thing out. Find the average rate of change of this function on each interval. So we want to find it from here to here, we want to find it from here to there. After computing your answer, confirm your results on a graphing calculator. Explain your answer in the context of the problem. So let's take a look. If these are my two x values, I'm starting at -2, and I'm going to -1. I want to find the change in y over change in x, or change in f of x over change in x at that point. These are two x values, so I got my x's. So what do I need to find? The y's. I need to find f of -2, and I need to find f of -1 before I start. I need to find the corresponding y values, write that down, with each of these x values. So f of -2, let's plug it in. -2 squared plus 3 times -2, -1 squared plus 3 times -1. I saw some interesting things happen this morning, so let's talk about this. Am I going to multiply the negative times the -2, or am I going to do the -2 squared first? Which one, Nelson? Nice one. -2 squared first. Exponents, GEMDAS. Exponents are going to become before the multiplication. So -2 squared is 4 with the negative in front. I've got -4 plus -6. Gives me -10. Cool. Go ahead and find the second one for me if you haven't already. You can write that down. Find the next one if you haven't already. Cool. Jacqueline, what'd you get? -4. Do you have a -4, which means now we're ready to do our change in y over our change in x. So our average rate of change will be equal to, which one do I use first? Does it matter? It actually doesn't matter. We just gotta make sure we pair them up right. So, pick whichever one you'd like. -10 minus -4. However, now, very important, if I started with -10, which x value do I need to start with on the bottom? -2 or -1? negative 2 because they're like partners minus a negative 1, like that. But you'll notice if you did it the opposite on the top and the bottom, you'll get the same rate. Okay? Do all that math, you should get negative 6 over negative 1. So we end up with positive 6 right there as our rate. Alright, now that's all cool and all. I like 6, it's pretty, it's a number. Woohoo, we found the average rate of change. However, it's important for us to think like, what does that mean? Okay, so let's talk a little bit about what that means in terms of our function. If you look right back above where it says say it, let's talk about what our answers mean in the context of the problem. Because every time I have you calculate average rate of change, I'm actually going to make you interpret your answer and like write a sentence about what it means. So let's talk about what our rate is telling us about the function. First bullet. Let's see, Dennis, can you read that first bullet nice and loud? When the average rate of change, that part.
The average rate of change for
A to B.
B's positive function is increasing average rate from x equals to a to x.
Okay, so in our case, we got a positive 6, right? Because it was positive, go with me? Positive. Since it was positive, that means the function was doing what? Increasing at an average rate of 6, because that was our value, right? From whatever it was, negative 2 to negative 1. So our function, I don't know, maybe it looks like this, and over here is negative 2, and over here is negative 1. From here to here, in this case, my picture would be decreasing, so my average rate of change would not have been positive, right? In our case, from negative 2 to negative 1, it was positive, which tells us on average our function was going up rather than going down. If it's negative, makes sense then, if it's negative, what's happening with the function? It's decreasing at an average rate of whatever the value is from that interval to that interval. Note! Very important. It says note right here. Let's see, Jacqueline, can you read nice and loud where it says note? What do we need to note?
The average rate of change is describing the average behavior of the function over the interval. A positive or negative average rate of change does not mean that the function is always increasing or decreasing over the interval.
Okay, remember we said the line is not actually our function. So the line, I agree, is decreasing the whole time or increasing the whole time. But our function, we're talking about what's happening on average. Let's say, here is my function. It's important we conceptually understand this, so I want to see eyes up here. Make sure you're watching with me, even though you're like, oh, I'm going to follow the next one. Try to follow with me for this one, okay? If this is our function, from here to here, do you agree? Part of it is increasing and part of it is decreasing, right? It's not increasing the entire time. However, would you say most of it, that's like a bigger piece that's increasing than the part that's decreasing, right? Therefore, look at the slope of this line right here. This would be a positive slope of this line, which tells us that on average from there to there, our function was going up. It was going up like more than it was going down, right? Okay? So it doesn't tell us about everything. Doesn't mean it's always increasing or decreasing. It means on average, the majority of the behavior is increasing or it's decreasing, okay? Cool, so based off of that, this answer right here, we can say, I'm gonna build on our answer, we're not quite done with this problem, we're not moving on to the next one yet. We can say that the function is increasing at an average rate of 6 from negative 2 to negative 1. That's like our conclusion, that's what the 6 is telling us. And so we're gonna always write what our answer means in the context of the situation. And this is going to be super important actually more when we get to like word problems, when it's a rate of 6 like meters per second or something like that. But in this case, we're going to still practice writing what that means about our rate. So because it was positive, it's increasing at a rate of 6 from negative 2 to negative 1. Okay, same function, new location. Now we're going to go over from 0 to 1. Let's figure out what's happening with our function. Go ahead. I'll let you for this one. It's okay if like you want to start independently, but since it's the first one, if then you want to kind of talk and check in with your neighbors, you can go ahead and do that. Go ahead and you guys find this one right here and be ready to share out. Go for it. Find the average rate of change from 0 to 1. You have 2 quick minutes to do that. Lovely. Yes, you'd say the function is increasing at a rate of 2, but this time the rate is not as quick, it's not increasing by as much as like earlier. So it's like slowing down from 0 to 1. Right? Because you're gonna have to, in a second, when we deal with word problems, your description is gonna have to be even more detailed. And what I noticed last year, because I kind of like let people like do the thing in the on-com assessment, but everyone had the number right, but people really struggle with explaining their answer. And that was like, so this year I'm gonna try to emphasize it a little bit, which seems annoying, but it's a work. Okay. So then we take these, find what those are equal to, and then do your change in y over your change in x. Yep. At lunch? Did they say something that you weren't allowed to? I think for the most part, they usually can, but what happened last year is like they don't think we're in the front office and couldn't work, because all they were doing was like taking lunches. I bet if your parents brought it, they brought it to you, the issue was that parents were like thinking last year, and then they had to say like, stop the lunches. I don't know, so you know, that's a question more for the front office, because it like doesn't affect me at all, but they were the ones that decided last year.
Teachers,
Like this one? Is that what you're saying? Is that where this whole conversation is moving?
Okay. Not really, but like, since you said, I was
Since they were like,
yeah.
what are you getting for me? Alright, I'm gonna pick on someone. Cecilia, over to you. Did I pick you last time? Dang it. Today is your lucky day. You 2 minutes on Ravel, because that was me. She got 2. In case you get something different, really quick, I'll show like the breakdown. I got 0 and 2, and then I subtracted and had 2 right here. Anyone else subtract like the opposite order? 0 minus 2 and 0 minus 1, you'll get the same answer because you'll have a negative on the top and bottom of pencil. Okay? Therefore, what can we say? Tanya, I'm coming over to you because I know you had it because I was over there with you. What can we say about this function? Can you tell me what your sentence was?
The function is increasing at an average rate of 2 from 0 to 1.
Cool? Increasing at an average rate of 2 from 0 to 1. So now we know with our, oops, lucky you got an extra. Now we know that both of these spots on our graph are on average increasing, right? But are they exactly the same?
No.
Can anyone like conclude anything else about from -2 to -1 versus from 0 to 1? What do you notice about your rates? Any conclusion? What do you notice about, what can you say? You said it's not the same. So what's different about the rates? Nelson, what do you notice is different? Okay, so something about here the rate is higher in terms of it's increasing at a higher rate with whatever that means. So that part of the graph is still gonna like somehow probably look different than the other part. Okay, so we've got a lot of information right here. Yeah, it might be, it's like more steep probably at that point. The line connecting those 2 points is more steep, which means something about the function being more steep as well. Okay, cool. Go ahead, independently this time for me. I'm gonna make sure everyone can do this on their own. 2 functions right here. I'm gonna set 6 minutes, that's 3 minutes for each one, to see if you can finish both of these. If you're working with a sense of urgency, 3 minutes should be time for both of them. So independently, 6 minutes to do 2 more problems. Do you still have
I don't know, I have too many players. Yeah.
That's not how it works. Independently on this one, on your own, call me over if you have a question. Because that's this zero is the X right here, and this zero is where, when I plugged in 0, I got 0 plus 0 is 0. So this is your Y coordinate, I subtracted my Y's, 2 minus 0, I subtracted my X's, 1 minus 0. Okay, so change in Y, we're always doing the change in these answers over the change in our X values, right? Here we did -10 minus -4, -2. Here we did the difference of these. Okay, so the first thing you're gonna do for this is find F2. But, wait, is that still mine also? Okay, because I was like, in my next class, I need it also too. Do you guys have that one with you? Get that one too, so you're gonna at least have 2, and then at the end of class, I can that one back. Yeah, this is 2 cubed to the third, so yes, it is 8, 'cause it's 2 times 2 times 2. And 2 times 2 is 4, 4 times 2 is 8. Did it work when you made writers?
Oh, yeah.
You don't have to work on that. Oh, gotcha. If you, in the case you don't have it. Wow, hard worker over there. Okay, you got 3 minutes, you've used half your time. So see if, we're working more on pacing now, see if you are done with the first one and moving on to the second one, you've used half your time. Good. So we do B. You got the process now. It's just your answer slightly. Perfect. Very good. Alba's going ahead, and now that she's got her answer, she's also writing it in a sentence about what's happening with the behavior of the function based off of her answer.
Multiply 4 times by 5. Multiply 5. I'm
really big. So when you typed it into your calculator, one thing that you have to be really careful of is you did great with the squared with your parentheses, but here you didn't put parentheses around the -5. So it's gonna put the negative out front instead of underneath the 4.
So is it 4 here?
That's closer. I think it's 4. 4 or something.
Yeah, because I got 4 and stuff, but I don't.
No, you need parentheses. You did no parentheses on either of them. You parentheses on both -5s. Because you want -5 squared. What it's doing is 5 squared is 25 and then putting a negative out front. You want -5 times -5 is positive 25.
Times 3 is 27.
Alright, wherever you're at, go ahead and pause what you're doing. To get some more participation points out there, what I'm going to do is I'm going to pick on some people, but instead of giving me your final answer, because like it's hard for people then to tell where their mistake is, we're going to first say like what we got for F2, what we got for F3, and then someone give me like the final answer, okay? So first up, Alba, what did you get for F of 2?
The whole sentence or just numbers?
Just we're going to break it down into what you got for F of 2, what you got for F3, and then the final answer. F of 2, what'd you get?
-6.
Close. Did I get it wrong?
Uh-huh.
I got it right? Okay, let's take a look. So
Yeah.
that way we can all find like where our, because I've had some people that have different answers, and it's helpful to figure out which one. So let's see. If I have 2 cubed minus 2 times 2 squared minus 3 times 2 plus 2, I have 8 minus 8 minus 6 plus 2. These cancel out. -6 plus 2 is 4, so close. I'm still going to give you a stamp for participating. F of 3, let me go with, Joanna's no longer here, no. Nelson, what did you get for F of 3? Positive 2 is correct, okay. Using those, setting up your average rate of change. Final answer then, Jonathan's also not here, our class is dwindling.
No, same.
Andres, what did you get for your final answer?
Positive 6.
Positive 6 is correct. Therefore, you could say the function is increasing at an average rate of 6 again from 2 to 3. Happy? We found all that stuff? Cool. All right. Next one. This one's getting a little crazier with the negatives to the 4th power and then negatives to the squared. So I saw some different things as I walked around, especially when people plug this into their calculator. So let's see what we got. Eileen, starting with you. What did you get for F of -5? Let's see. Correct. So y'all in the back, I know we were kind of debating which one it was. 455 for that one. Something to note for all the tables, something to note. If you type this into your calculator, you've got to use parentheses around the -5 to tell your calculator that you want the 4th power of the -2. If you don't, it thinks the negative's out front. Okay? F of -3. Edo, what did you get for F of -3? Not there yet? Who's there? 15 is correct.
Yeah.
And then setting up that change. Final answer, anyone that got all the way to the end? Yep. Correct. -220. Therefore, one more time to conclude. Who else should I get? One more time to conclude. We could say this function is doing what? Decreasing at an average rate of, listen carefully, at an average rate of 220. I don't say decreasing at -220. That's like I put 2 negatives on it. I say decreasing at 220, positive 220. These are rates. It's like a speed. I wouldn't say that I'm traveling at -40 miles per hour, right? Like I just would say I'm traveling at 40 miles per hour, and then I'm either increasing or decreasing or going like a certain direction or something like that. Okay? Cool? All right. Very good. We're going to spend the rest of the amount of time doing the same skill. So nothing different, except we're going to talk about in a word problem how we actually have even more things as we explain our answer that we need to make sure that we include. So if you look at this box right here, I believe it's at the top of the next page. Is that right? Yeah. At the top of the next page, there are 6 characteristics that I have like broken down that they will be looking for when they grade. Like if I'm grading a unit exam or on the common assessment, the number is all fine and dandy, but like you need all 6 of these things to be able to get full credit on a question like this. Some of them we've kind of already talked about. You need to give me the time interval. So remember, these are different depending on where we are on the graph. So you need to say from 2 to 3 or whatever it is. That's what we're talking about. The description of the function, earlier we just said the function. Now you're going to say the number of people, or like whatever we're talking about, okay, is what's happening, increasing or decreasing, what's the behavior. At, you need to acknowledge that it is not a set rate that's true for everything, at an average rate of, and then whatever, however much, so like in the last example, 220, right? And then what we have not had yet is units. Now you're going to say like miles per hour or meters per second or something like that to describe your rate, okay? So let's look at an example. I have it up here as well. Positive is increasing, negative is decreasing, and then I have all 6 of the different things you're going to need on my poster up here. So when you're solving a problem like this, you can literally like check and make sure you didn't miss anything you need, okay? Well, let's take a look at this physics question and see how we do, and then you're going to practice the next one on your own, okay? I'll read this one to us nice and loud. Follow along with me. The height of an object, ooh, I know what I'm talking about now. The height of an object that is thrown straight up from a height of 4 feet above ground is given by h of t equals negative 16t squared plus 30t plus 4, where t is time in seconds after the object is thrown. Find and interpret the average rate of change for the height of the object from 1.25 to 1.75 seconds. In physics, the average rate of change of the height is referred to as the average speed. When we find the rate or the average over time, it's the average speed. Yep?
Is the reading used it for, or is it just
This right here?
Yeah.
That you're like, why didn't she box 4? Like, that's important. It's a number. Yeah, it's just telling you that it's 4 feet above the ground, which if you think of our average rate of change, we're going to be wanting the time, right? The interval of time. And then we're going to be wanting the change in the heights, but at these 2 points, right? This is 4 feet above the ground, so that's like when we're starting. So maybe that's at like t is 0.
That's what we're looking
So we might want that if like we're concerned about the starting point, but let's see when in a second, because we want to talk about these 2 times, which are going to probably have different heights, okay? So in general, we're still going to do the same process as before. We've got 2 x values, or in this case, t values, right? And we need to find now our 2 h of t values, right? So we're going to start with h of 1.25, write this down, and we're going to find h of 1.75. And for the sake of time, because we just practiced a lot, like just calculating, I'm just going to go ahead and like, say we plug them into our calculator and we found them. For those 2, you're going to get 16.5 and 7.5. So I'll just kind of do the math for you to speed us along. When you plug them in, you're going to get 16.5 and 7.5. So Dennis, over to you. Can you tell me then how we would find the average, like what you and I talked about? What are you going to be subtracting if this is what you get as your h of t and those are your t values? Help me out. What minus what? What can we start with?
16.5
Not quite, because you're doing then a y minus an x. That would be this minus this would be you're taking like a y value minus an x value. This is change in y, the 7.5, good, over on the bottom. I'm now going to do these, but I got to make sure I put the first one correct. Which one goes with 16.5? 1.25. These are matched up together minus 1.75. Cool?
Yeah.
Okay, we calculate that. Again, I'm gonna pretend like for the sake of time that we can plug that into our calculator. And you should get negative 18 when you do that math. So, the goal now is to make sure that we can explain what this negative 18 means in the context of our problem. And I'm gonna bring this box back. I need all of these 6 things to make sure that I'm really describing the situation accurately, okay? So I'm gonna show you my sentence first. Don't write it yet. I'm gonna show you my model sentence. Don't write it. We're gonna check that I have all 6, and then y'all can write it down, and then you're gonna do the next one, okay? So here would be my model sentence. Yours does not have to be exactly like this. It just needs to make sure that you actually have all 6. So here's my sentence. From 1.25 to 1.75 seconds, the height of the object is decreasing at an average rate of 18 feet per second. So let's talk about that. Time interval. I have my time interval. I'm gonna underline it right here. Check. The description of the function. You have to describe what it is. You can't just say the function. What is our function h of t describing? The height of the object. So that's my description. Is, what's it doing? Decreasing, because it was negative. Okay, I got my behavior. At not just 18 feet per second, that would be like all the time. But remember, this is an average rate, so I have to say at an average rate. I just need to acknowledge that the change is an average of numerical answer 18. And notice, did I keep the negative on it? No, because like I talked about earlier with like a negative speed, like the negative is the decreasing. And then my units are something per something. So let's talk about what our units were. This top part was talking about our height, and that was in feet, right? We took feet and we divided by time, which was in seconds. So we have feet per second. It's always going to be like the unit of this top thing per the unit of this bottom thing. Feet per second. And then we have all of the things that we need for like full credit for average rate of change. Last year I had majority of people get this, but it ended up only being like half of a point. And most people I couldn't give full credit unless they had all 6. And someone was missing something. And it was really hard for people to get full credit on this. Okay? Cool, we got it all? Alright, here's the test then. New problem. I'll go back. New problem. I want you to do the one below this one. And I'm really going to be checking your sentence. I'm going to have like maybe like 2 or 3 people read their sentence to make sure that they have all 6 things that they need to have to explain what's going on in the problem. Okay?
Before was just there.
But it like could have been because it's describing where it started. So that's like almost like t0, right? So if our interval would have been from like 0 to 1.75, then this 4 would have been our like height, that like h of t value. Yeah. So.
2, 3, 4, right? 4, 6.
Yes. Solve it, and then write your model sentence to make sure you got all the things you need. so that's just that's the one part. And then divide that by the 4 times 2, or no, the opposite, 2 times. So now writing your sentence. Okay, that's 2 minutes for calculating. If you haven't already, finish up the calculating. I'm gonna give you about 1 more minute to write your sentence if you haven't already. Then, like I said, I'm gonna have like 2 or 3 people share their sentence to make sure they have all 6 pieces. One more minute. Seconds. So we need all 6 of these things. So you need to tell me from where to where. So we're talking about from what time interval? I'll tell you specifically. Decreasing of 96 and units something or something. So think about what the top is and what the bottom is, because this will be something or whatever the bottom. So the top, the height was in, and then this 2 and this 4 seconds, so you'll say 96. Okay, let's see how we did on the sentence. I'll go ahead and share the value, because at this point we've done a lot of practice with that. I got negative 96. If you got something different, take a look at like my values, that where it came from, and you can kind of try to check your work that way. Miss Gladys, did you get a chance to write your sentence or start it? Okay, anyone in here that did? Jacqueline? Okay, Jacqueline, give it a shot, and I'm going to try to go through my 6 things and make sure you have all of them, okay? Go for it.
T equals 2 and T equals 4, the height of the object is decreasing at a average rate of 96 feet per second.
Feet per second, I heard all of them. I went through as she went. That one was very similar, honestly, to the problem before. So you could have kind of just like used mine and plopped in the new values. That's what I did right here as well. But we got time interval, what we're talking about, the behavior decreasing, the fact that it's an average rate, the number, and the units, okay? All right, in closing, we got 3 minutes left. That's the last problem that's on here. On your problem set, there's a new problem set that you can find in the blue folder if you haven't already grabbed one. That problem set, the date on the top is wrong because like with the hurricane, I didn't know when I was gonna make it due, and I accidentally printed it with like last year's date on it before I changed it. So if you grab your problem set, it says like Tuesday the 18th, next Tuesday isn't even the 18th like this year. So I want you to change that to what we talked about last week, which is that you have not until just Monday this week. This time I'm gonna give you some extra time until the unit exam because of people just still dealing with stuff. So Wednesday is, I believe, the 20th, our beginning of our unit exam. So I'll keep giving you plenty of reminders, but just so you know, if you want to write it on the top of your problem set, it's due Wednesday the 20th. And if you take a look right now, you should be able now to do problems 1 and 2 on the average rate of change. Cool? Okay. Before you jump to that, I want to show you one quick trick that last year, again, this is fun because you guys get to see all the things that last year, like the kids weren't prepared for. Last year there was an average rate of change problem on the common assessment that got kind of tricky with the units, and as a result, a lot of people were not able to get like their unit point even though they knew what they were doing with the average rate of change. So I want to talk about that in this problem right here. So if I can still have everyone's eyes on this problem, because I'm trying to like save in case you see this on the unit exam or common assessment, now you'll know what to do. So it was a situation different than this but similar. where I've got a function that represents money entering a bank account at a rate modeled by the function. So the function is not just talking about how many dollars, it's already talking about dollars per week, like a rate. And then we're finding the average rate of that rate, okay? So when you do your math, we find N03, we find N07, we do all of our math, we get our answer. When I'm trying to figure out my units, this is dollars per week. And then I divided by 7 and 3, which is time again, which is weeks again, which mean your units end up being, this is like the tricky part, this many dollars per week, per week. See how you have to say like per week, and people are like, that couldn't be right, no one did that. But if it's a rate of a rate, it's dollars per week again. So I like divided by weeks again. Okay, so then it's possible to have a rate of a rate. Happy? Bye-bye.